Hello, I'd like to do kind of a show and tell. My water Pogo 6, or WP6 for short, water rocket with a folding wing, flex wing arrangement, or a Rogallo wing officially. This is obviously the sixth in a series of water rockets I've done with that are turned into gliders. The first four, this took a year and a half, been fussing with this. The first four were folding wing gliders like the A.J. Walker. They had multiple rotation wings. They folded back along the side. They had apogee. When the rocket slowed down, a rubber band pulls the wings open. We started out small, about the size of this one, 28-inch wing. But the final one, the 4 right now, has a 60-inch wing total. And that's a whole other story, but we've been through a lot of fussing, and it actually turns into a very good glider with the elevator, rudder, and ailerons functioning. So pretty cool. But we wanted to get into this Rogallo wing because it shows the most promise. It's kind of like a cross between a wing and a parachute. This back in there, you can see the wing itself. The keel is 24 inches long, and so are the outer spars. In the center is there's a little small block that the spreaders are mounted on, and they're on a double keel. The last 2/3 of the keel, I don't know if it'll show up here or not, are double, high-low. And the block slides on there. There's rubber bands at the top that pull it forward. So you pull the block back, the side shrouds come in, and it folds up into a very small bundle, which in turn gets mounted along the back of the body tube of the rocket, and then is covered with that red piece of poster board. Wrapped up with the rubber bands and held in place around the edges of the servo here, which is then in turn connected up to the receiver, and we're using the landing gear switch. Pop that thing and the rubber bands fly open. Hopefully we've done drop tests on it without the lines connected, and it works just fine. So when we finally get into it, I didn't want to put the wing on it yet because it would cover up so much of the body tube you wouldn't be able to see anything going on. So hopefully when we get it all together, the idea is that at the apogee at the top of the flight, I push the landing gear switch, the rubber bands let go, the wing pops open, and now we have a nice glider. But we'll start up here at the nose cone. Nice place to start. The whole body is 36 inches long of pressure chamber and tube, and there's another 6 inches for the electronics in the nose cone. We have a Spectrum AR400 receiver, and there's also an altimeter 1 in there to give us a reading that's just behind the receiver, and it gives us a reading of the altitude at the peak altitudes. The whole thing is powered by a 600 milliamp one-cell lithium battery. It was turned on to that by I skipped the Delta wing number 5, WP5. A good time to cover it. This gentleman is doing pyro rockets made out of styrofoam. It is a Delta wing. It's dinosaur rocketry. They're out in Oregon, but he's been a big help to me, and this does work out. We did try one of those with the Delta, and it has some promise. So it has some trimming issues, and we'll keep working on that. But I wanted to get into this. It just got exciting, and I kind of got sidetracked. But anyway, there's the electronics package up here in the front. The entire pressure tube is off limits to anything except water and air pressure. So right, the transition point between the electronics and the pressure tube is just a shrunk down bottleneck. It's covered. You spin all the way to the back here, and you have the rocket nozzle. Again, the launchers and everything else is a whole other story. If you're really interested in water rockets, there's an Air Command water rocket site, and U.S. water rockets are I found to be the best. They're very well documented. Air Command is in Australia, of all places, but a gentleman by the name of George, I've been emailing him for well over a year now, and back and forth, and he's been very helpful. But both sites are just loaded. It would take you a week to go through them all. Very interesting stuff. Okay, we have the pressure chamber. Goes over the launcher, goes over some O-rings, pressurize it in the area between 80 and 120 pounds, depending on what kind of performance you want. The chamber itself is 1.2 liters of volume, and the rule of thumb is that you put 1/3 of that in as water. So you have about 0.4 liters of water, bring it about up into this area. When it releases, they use cable ties that pinch down around the rim of the nozzle. You pull that down when it releases, and away you go. So that's pretty kind of straightforward. You're interested in the water rockets, to go to those two sites and check that out. I think I may have mentioned, but the inside of this, you can't put anything inside the pressure chamber. So all the servo wiring goes down the belly of the bottom of the rocket to the back and whatever else you want to go. Now that little pigtail hanging out there with the red, black, and green lines, that's what I call the reverse umbilical. That's connected to the throttle channel. And on my launcher, I have a small servo that pulls a lever inside of a black box, which I still say is classified and secret. That in turn snaps and pulls down the launch collar, and away we go. So we can launch any of these rockets, and I've used so far used the same launcher for all 6 of them. You can launch all of them from the transmitter just by popping up the throttle switch. Those connectors are little gold round things. They have some interference when you slide them together, but they really can't hold up to the 100 and some odd pounds of thrust coming out of this thing at the initial burst. So they just part their way, and they're ready to reconnect the next time. Pretty cool, really. The other thing, let's see, we're gonna fold this guy up. That slides down, that block on there slides down, folds up the wing. We stand it on top, and here's a stop block here to key. It's at the very back of the keel, gets fastened into there. That stop block prevents the keel from sliding back when you're looking at 25 or 30 or 40 pounds, 25 or 30 or 40 G's of thrust during the liftoff. If it wasn't there, it would just slide it right out from under the rubber bands. But when we get to the top, we give it a pop and it comes open, and the whole idea is there's quite a bit of incidence on that, about 15 degrees incidence. No, I guess 12. I had it set up at 12. And it comes open and turns into hopefully a very nice glider. The tail feathers of this one are also, that's pretty much common, using the corrugated sign material plastic in there. I've got a high-tech servo on the rudder, and right now it's kind of rudder only because I'm really envisioning this thing as kind of a guided parachute with some forward motion. But we're not going to be real fast, so we put a giant rudder on there. I've got the spreader arms there, or whatever, the little servo link-ups. I added one of them into the rudder, tied them together with some fish line. These are featherweight servos, and the little receiver draw very little current. That's why we can get away with using that lower voltage lithium battery. But if I can't get that to work, I'm going to run lines forward and pick up the lines that come into the spreaders on the outer part of it. I should be able to rock the wing and get it to steer that way. But we're going to start out with the rudder first, mainly because it's the simplest and don't have to have more fishing lines running every which way. But that's pretty much it. Hope you enjoyed it, and we're going to look forward to, here in the next couple of days, I'm going to mount the wing, and we'll do a drop test of that. I've already done drop tests of it without it being mounted, but we're going to mount the wing, and hopefully everything deploys well, and then eventually we're going to go to the field. And we got link up. I'll hold this upside down. We're going to take a picture of what happens to the rubber bands as we flip the landing gear switch. On your mark, get set, go. I think it worked. I think it worked. Okay, remember I promised we were going to do a video of the entire drop with the wing completely loaded, and it'll deploy as it pops out. And today's the day. And I've already done it once because I didn't want to record a failure. Hopefully it's going to happen again. Before we go on, though, I had 2 points with the water rocket that I forgot to kind of mention, that the physics of these are just unbelievable. You know, Newton's third law says for a reaction there's an equal and opposite reaction. This rocket, this model water rocket, holds just a tad less than a pound of water, and then with 100 some odd pounds of pressure PSI in there, that thing is when it's released, it goes. The water leaves the rocket in about less than a tenth of a second, and it's burned out, or it's out of water less than 10 feet off the end of the launcher. So it's expended all of its energy just coming off the launcher. The rest of the time, up into the 200-foot range, it's coasting. So it's one heck of a slingshot. So that's pretty much the physics of a water rocket. The other thing is, along in there is the one where I mentioned about my my little pigtails here going down into the launcher and holding a micro servo that in turn operated a secret device inside the black box. Well, I'm ready to tell you what it is now. It was really a rat trap hooked in there. It pulls the servo pulls the rat trap release sideways. There's 2 lines fastened to either corner of the jaws of the trap. They in turn go through a couple of pulley blocks just below the launcher where the cable ties are locked around the base. There's a collar that locks the cable ties in place, so that rat trap, when it goes off, it yanks that collar down instantaneously, and that's how I'm able to launch using the radio at a remote distance. But where we got here now, I have to go get my transmitter. I apologize, I didn't bring it with me. It's right behind me here. We're going to do the deploy upside down again because I don't have any air moving over it. I plan to launch it about maybe a 15-degree off of vertical, and hopefully this thing is going to go up and arc over without any rolling. And most of the ones that I've built so far are true enough that they don't do that. So if there's no rolling and it's just at the top of the apogee, when I hit that release switch here, it's going to, of course I have to hold it upside down because we don't have any wind, but the wind going by, the air going by this thing is going to peel it away and hopefully deploy it. Now we're going to have a glider to bring down. But like I say, this does work, and I'm about ready to prove it to you. Again, I hope we're ready to go maybe. Yeah. Got rudders going here. See how far the rudder swings? It really gets all over it. And hopefully, even though we're going to have relatively slow glide speed, it's going to do its thing. Now, I'm going to lift this thing up a little bit higher than before because it drops down quite a ways. And what we're going to end up with is a completely deployed Rogallo wing, ready to fly, 12 degrees positive incidence, and the balance point's about right in this area right here. It's a lot farther back than I would think, but it was done by trial and error, and it just glides like a champ in that mode. So here goes. I'm not even going to say a countdown or nothing. Here, watch for the rubber bands. Look at that. It worked. It absolutely worked. There's my angle. All the lines are clear. Packing is quite a bit of fun because if you get those lines all messed up, it's all over. I want to thank Terry. He's got his own blog and he writes a number of articles for the Model Aviation magazine, the AMA, and he's been doing my editing for film editing for me. He's also encouraged me through this project. So thanks a lot, Terry, and we'll have some more video for you. Hope out at the flying field when this thing is actually right side up with the wings fully deployed. We can't get even any air in them in here, but that's the way it goes. Upside down is the best way to show it to you. You can always turn your monitor over if you'd like to see what it looks like in the air. Have a good time. Thanks a lot.